Hey, what's going on, guys? Mr. Flores here. This is the first video for solving a system of equations. Okay, so basically if you are not here to watch a system of equations and how we solve them, I don't know where you should be, but you shouldn't be here, so figure it out. But if you are supposed to be here, thanks for coming. So if we got here, really this year we've been dealing a lot with equations, okay? Now, when you hear the word systems of equations, what do you notice is different about the word equation? Well, hopefully you can pick apart that the word equations as opposed to equation. Okay, it has an S. Equation. Oh wow. All right. Let me try and spell it again. Okay, equations. Equations. Okay, the word equations and the word equation. The difference is that equations is plural, equation is not. So basically, when we talk about a system of equations, really all it means is two or more equations that have some type of relationship. Okay, we're going to get more to that relationship a little later, but just know that a system of equations is two or more equations that have some type of relationship. Okay, but before I get into that, I just want to go over the main two ways we've been setting up word problems this year. Okay, so when you set up word problems, there's really two main forms. There's slope-intercept form. Okay, so there's slope-intercept because word problems come up a lot in systems. Word problems also come up a lot all the time. So hopefully by now you guys are seasoned veterans. But in case you forgot, we have slope-intercept form. We also have standard form. Okay, both of which are interchangeable, but depending on how a word problem is set up, you're going to basically be giving it different. You're going to have to set the problem differently. But again, these aren't the only two ways you can do word problems, but these are the most generic, the most common ways we use. So slope-intercept form, we know is y equals mx plus b. And standard form is ax plus by equals c. Okay, so you have y equals mx plus b, ax plus by equals c. All right, and basically you put an equation in slope-intercept form if you have a begin value, okay, and then a rate of change. So a rate of change. And again, this isn't new. This should all be review, but in case you forgot. Okay, so if you're given a beginning value and a rate of change for something, it's going to be the equation in the slope-intercept form. If you're given a total value, okay, and two rate of changes for two separate things like apples and bananas, multiple choice and true and false questions, two rate of changes, it's going to be standard form. So I should say it off. Okay, that's a little disclaimer, a little thing we've gone over because you're going to do word problems a lot with systems. You're welcome. I know you love them. So back to systems of equations. It's two or more equations that have some type of relationship. So let's jump right in onto a problem. The first way that we're going to solve systems of equations, okay, is we are going to be solving them using graphs. Okay, graphs are cool. Graphs are fun. And if we look here, the problem says that we have our friend Sarah and our friend John. Okay, basically John and Sarah work at a supermarket. At the beginning of the week, Sarah has $1, John has $3. Every day, Sarah makes $1, John makes 50 cents. We're going to create two equations to model this situation. Then we're going to graph them on the graph given. Okay, and basically we're going to create a system of equations because we're going to have two. All right, but if we think about it in the beginning, we know that Sarah begins with $1. Okay, John begins with $3. So right off the bat, we know that we gave you a beginning amount, okay, a beginning value. So if you remember from word problems, or we go back, slope-intercept form is when you're given a beginning value and a rate of change. Well, we're given a beginning value, so we know that we're going to have to put our equations in slope-intercept form, okay? But now we just have to look at the word problem and find out what the change is. So every day Sarah makes $1, so she gains $1 a day. Then we know John makes 50 cents, so John gains $0.5 oops, I can't find a cents case, so I'll just do $0.5 a day. All right. We found out their starting values. We found out their rate of changes. So now we have to build the equation. So for Sarah, she begins with $1, which is going to be our y-intercept or our b, and she gains $1 a day, which is going to be our slope. So Sarah is y equals x plus 1 because she begins with $1, which is our slope, which is our y-intercept. She gains $1 a day, which is our slope. John, on the other hand, is going to be y equals 1/2 x plus 3 because John starts with $3, beginning is our y-intercept, gains $1/2 a day, our 1/2. Okay. Now we created our two equations to model the situation. We created a system of equations because we have two equations that have some type of relationship. Okay. Then it asks us to graph them. I'm gonna graph Sarah in orange, John in green. All right. So Sarah, she has a y-intercept of 1. Okay, and then she has a slope of 1. So we go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Now, when we graph lines, I know that we only need 2 points for the line, but when we talk about systems of equations, we want to find out a certain point on the graph. So make sure you put more than one dot, okay? Just makes your life easier. Trust me. Just make more than one dot. Now I'm going to graph John in green. John has a y-intercept of 3. Okay? And John goes up 1 over 2. Up 1 over 2. Oh, whoops, I actually graphed this wrong. Sorry. Hopefully you caught my mistake before I did. We have a y-intercept of 3, so John's right here. So he goes up 1 over 2. Up 1 over 2. Up 1 over 2. And we're going to draw John's line. Okay? So, we have the orange line being Sarah, the green line being John. All right, and now we want to find out what is common between those 2 points. Okay, well, we know that both graphs intersect at this point, which is 4, 5. Okay, and that's a very, very important point. Okay, because the next question down here says, what do you notice about the relationship between their lines? Well, the 2 lines intersect at a given point, or more importantly, at 4, 5. Okay, so we notice that the relationship between the lines is that they intersect at 4, 5. What do we call this point of interest? Well, we call it our point of intersection, or our solution. Okay, because the whole point of a system of equations is to find out where do the 2 equations meet. Okay, so graphically, what's the coordinate they meet at? All right, so we know that our answer to this system is going to be 4, 5. But what we need to do now is we need to take this and relate it back to our word problem. We knew that X stood for the amount of days she works, and the X is 4, so it takes 4 days. Okay, and we know that Y in the equation is the amount of money they have, so it takes 4 days to each get $5. Okay, and that would be our answer to this system of equations. We solved this graphically because we graphed both our lines and saw they met at 4, 5. All right, which is good. That's all systems of equations is, solving them graphically. You take equations, graph them, see where they meet, and then write the coordinate. If it's a word problem, you must label. It's really not anything tricky, okay? At least graphing them. There's other ways, which we're going to find out later on. The one way is called elimination. The other way is called substitution. Again, neither way is crazy hard. They're just a little different. And we have one last question here. How else could the 2 lines interact on the graph? Okay. Well, if we look up here, we have 2 lines that meet once. Okay. These lines are straight. They're never going to come back to one another. So the lines can never meet more than once. But we got to think, what are other ways that graphs can meet that isn't 1? And I just said it can't be more than 1, so you got to think different. All right. So let's actually go to the next page. So on your next page, you have 3 graphs. Your graphs are looking a little different than mine, but it's okay because as long as you have 3, you'll be good. All right. So we already figured out one type of answer we can get for a system of equations. Okay, and that is one solution. Okay, so we can have one solution. All right, and that's when our graphs meet. Okay, it's just the point of intersection is going to be our answer, and that's one solution. Hopefully, you're thinking of different types of lines we have. Okay, and what do you remember about two lines that are parallel? Okay, so parallel lines. What do? Well, they definitely don't ever meet because that was the definition of parallel. Okay, so parallel lines are never going to meet. So again, we said the answer to a system of equations is the point of intersection. Well, if two lines are parallel, they're never going to intersect. So two lines that are parallel have no solution. Okay, and the other thing you can write is null set. So the second type of answer is no solution. That's for lines that are parallel or they never meet. Okay, the first type was one solution. Second type was no solution. Okay, now what happens if we have two lines that are exactly the same? Okay, so this is two lines on top of each other. Well, are those lines ever going to not touch if they're on top of each other? The answer is no. Two lines on top each other. My pen's a little quirky. I don't know why. So two lines on top of each other. We have to ask ourselves, are those lines ever going to not touch? No. If they touch forever, the word in math that means forever is infinite. So we have two lines that have infinite, or a system of equations with infinite solutions. Okay, and that is two equations that are exactly the same. All right, so these are our three types of answer we can get. We can get one solution, no solution, or infinite solutions. Okay, a system of equations, these are the only three types of solutions we can get: one, none, or infinite. Okay, we're going to look through some of the other examples to basically see what's going to happen. All right, so we have two equations here: y equals negative 3x plus 2, and y equals 2x minus 3. Right, and we're going to graph these on the line, on the graph, and we're going to find their intersection. I'm going to graph top one red, bottom one green. Top one blue, bottom one red. So the top one, it's y equals negative 3x plus 2. We're going to graph up here at positive 2 is our slope, our y-intercept. We're going to go down 3 to the right 1, down 3 to the right 1. Okay, if you forget how to graph in slope-intercept form, you're going to have trouble with this, so make sure you come and talk to me. Again, it's very, very easy. You have to find your slope and y-intercept, and you're good. But if you have questions, pause the video, come find me. So our red line is y equals 2x minus 3. So I'm going to go down to y is negative 3 for our y-intercept. I'm going to go up 2 over 1, up 2 over 1. Okay, and I'm going to graph both our lines. And again, our answer is just the point of intersection. So our answer is right here at 1, negative 1. And that's it. The answer to this system of equations is 1, negative 1. It's the point of the graph where the two lines meet. Right? And one of the things we notice is that right from the get-go our two lines, okay, they're totally different equations. If both your equations are completely different, you're always going to get one solution. All right? That's just something to remember, and that's something that's always going to happen. If you have two lines that are completely different, as long as they're straight linear lines, you're going to get one solution. All right. Now we have a different system. We have y equals negative 1/2 x plus 5, y equals negative 1/2 x minus 2. Hopefully, right when you guys saw this system, the word parallel comes to mind. Because if we remember, two lines that are parallel have the same slope, different y-intercept. Well, our two equations here have a slope of negative 1/2. This one has a y-intercept of 5. This is a y-intercept of negative 2. They have the same slope, different y-intercept, so we know they're going to be parallel. If we go back, we know that parallel lines have no solution. But you still have to graph it because I'm asking you to graph it. Okay? But if you get this problem and you graph your lines and somehow there is a solution, okay, if your lines intersect somewhere, you know you did something wrong. Okay, because right off the bat, we can use our context clues. That's a good English term, I think. We can see that these equations are automatically parallel, so they're automatically not going to touch, aka there's going to be no solution. But you're going to have to graph them anyways to show me that you know that. because I can't read your mind. But that's, again, a way that you can know your answer before you do the problem. Okay? Seems simple enough. All right. So there are a couple more you can graph. Actually, I'm putting for you. But the one thing I want to do is I want to go back to Desmos, okay? Because Desmos is a online graphing calculator. If you have a TI-84, you can do the same thing. It's just a little different. But basically, you can take an online graphing calculator on Desmos. We've used it a lot. We've graphed lines before. You can actually enter a system of equations, and Desmos will give you the point of intersection or your answer, okay? So let's use this one. I'm going to go to Desmos, and let me make this full screen. Effects, tools. All right, one second. All right, for some reason, it's not letting me change the size of my screen to capture, okay? So hopefully you can see all this right here in Desmos. So what I did was I went to Desmos, and I'm just going to type our first equation. Y equals negative 3x plus 2. Okay, that's our first equation. Now I'm going to press enter and go to the second line, okay? And I'm going to enter our second equation. Y equals 2x minus 3. Okay, so now we have our two equations, and their system is graphed on the graph. Okay, now all we're going to do is you click one of the graphs, and the intersection comes up here as a point. Okay, so I'm going to zoom in so we can see a little better. So if I click here, we see that the intersection is 1, negative 1. If you notice, when we graphed, we got 1, negative 1. It's not a coincidence. It's actually, that's math for you. But again, that's how you can use Desmos to help you out. Okay. Again, Desmos is a great tool, but it's only as good as the person using it. So make sure you still know how to do this on your own. But always check your answers with Desmos, because as long as you type the graph in right, it's going to be good. All right. Hopefully you don't have any questions with this. We're going to do some more word problems, so stay tuned. Hopefully you took notes in your packet. Hopefully you're following along. You're really understanding the material. Again, if you don't understand something, make sure you pause the video, raise your hand, ask me a question. If you have anything else, let me know. If not, hope you enjoyed.